for um, uh, accepting our invitation, and I would say the floor is yours. We have usually we have around about half an hour to 40 minutes talks, and followed then by a round of questions and answers and discussions, and we will stop around 1 o'clock, if that's okay for you.
Okay. Yeah, thanks, Martin. Thanks for the introduction. Happy to talk about polarization and how the empirical reality of polarization is, with a specific focus, and then how agent-based models of opinion dynamics relate to that or not so well relate to that. That's the topic of today. It includes a lot of joint work, and also Martin Neumann's name is on here. So so these are my co-authors. So what I want to do today is to speak about 5 things which are all related or building upon each other, or relating to each other. The first thing is about the question of how to measure polarization. So I will not spend much time on how important polarization is, or that it's increasing or not. So we'll come to that afterwards, but I just assume polarization is somehow a topic. So everybody's talking about it sometimes, everybody sees it rising for forever or something like this. But let's now go a bit more into how exactly can we measure it, and how can we exactly measure it in one dimension. So I'll spend some short time on this. Then based on this more narrowed down, more specific focus of what polarization we are looking at, we'll look at a lot of empirical data of attitude distributions and try to assess, what is the polarization in these distributions. And then I'll present, while looking at this distribution, we may see some kind of interesting empirical phenomena. So these distributions, they are not normal distributions. Usually they look a bit different, and this would be the starting point for some of the next topics. So the third topic will then be to try to make a data-driven model, how we can understand these distributions and see how far we get with that, and if it is of any use. Then I will totally change the perspective and present to you an agent-based model of opinion dynamics, which somehow works in the same framework. So it also has always as an outcome there is an attitude distribution or opinion distribution. These terms will be used interchangeably. So there is an opinion distribution always in the model, and this may be related to the empirical data. So that's the link, but the type of model is totally different. So we'll start by modeling interactions of individuals, and then make an artificial society, and then see how these agents exchange their opinions and what opinion distributions or attitude distributions emerge. And then finally, I'll look very briefly on how far we get with the agent-based model to being able to reproduce the empirical attitude distributions we see. This will not be perfect, so it's a bit of the long-term research agenda I have. So it's not. So it's built on some publications, but it's also has some open questions. Okay, starting with the first thing is, so what is polarization in this talk? So building on a general definition of polarization, which is polarization is the accentuation of differences. So this is still quite abstract, or at least quite general, can include several different concepts. So I'll just try to specify for this talk what it is, and especially what it is not. So in this talk, we'll talk about polarization unidimensional. So what does it mean? So this is not about ideological alignment over multiple issues. So often polarization is also thought about, when abortion and redistribution and several other conceptually unrelated topics, when there's always they are all aligned. So right people are against abortion and against redistribution and against this and against that, and left people are against it, and so on. All these things are not related per se, but they become related, they become aligned, and they become left or right-wing topics. So that's ideological alignment. Also a very valid concept of polarization, but not what we'll talk about today. So it's also not about issue partisanship. You can also say often, especially in US politics, you measure polarization. Okay, let's ask Democrats, let's ask the Republicans. We anyway only have these two camps politically, and look at what they think about different issues, and the difference between the average opinion of this group and the average opinion of that group, that's increasing. So that's large. That's polarization. So this pre-assumes that we'll have already some existing partisan groups, and we'll look at then differences in ideology on one dimension, but with these pre-existing groups. So we're also not about this, because this would include another dimension, the partisanship. So we don't have that. So we'll just want to work with one dimension, one issue, so to say. Okay, we'll look onto polarization of attitudes. So polarization is also a notion in income analysis or employment or ethnicity, but they're not so prominent there. But these notions also exist. So polarization of income being something different than inequality. But okay, we'll not deal with that. So it's all about attitudes. It's about ranging continuously between extremes over moderate and neutral. So the important point is here that we'll have something which can continuously change in a sense. So meaning that it's not just yes, no things. So it's something where we can be more or less extreme or neutral or moderate or something like this. Okay. And then this talk is also about political or politicized topics. So that means it is not about polarization in fashion or whatever, music, art, or something like this, but political politicized topics or politics near topics. And it's also not about affective polarization. That is another issue which has become a topic recently, which is affective polarization is mainly that we'll have the political groups, and okay, maybe they do not differ more in their attitudes, but they just hate each other more. That's affective polarization in a sense. Okay, and it's also important. It's about the general population. That means that we are not talking about polarization of elites, of parties, of media. So it's really about general population. That means we'll look at population surveys, which try their best to be representative of the general population. So that's the data we will have. So it's about polarization in general population, not polarization of the party system or polarization of the media. Of course, all these things are related somehow, for sure, but this is not the focus here. Okay, and this is the empirical data we have. This is a kind of snapshot of the empirical data. Actually, all the 8 things around this is not empirical data. This is just a normal distribution discretized to 11 bins. But all these 8 things around it are empirical attitude distributions. So this is, for example, the attitude distribution about trust in police in Norway. So you see, most people give it an 8, which means fairly high trust, or many people give it a 10. Very few people give it a 0. So it's not a normal distribution, but it's a fairly simple unimodal distribution. Similar for the opinions of if everybody has a fair job chance in Norway. Also quite a bell-shaped unimodal distribution. We also have other questions. For example, the question about the European unification or attitudes about European unification in Norway. This is a fairly more political topic than the other two, which are, of course, also related to politics, but not directly politics. But European unification means here, these are the people that say European unification has gone too far. this is represented by 0, and represented by 10 is European unification should go much further. So maybe Norway should join the European Union, and here we should not have much relations to the European Union. So, and you see here the distribution is already a bit different from the ones before. It's not so bell-shaped. It's more like fairly not really uniform, but many bins are populated equally. There's a large central bin, but not in this bell shape anymore. So, but it's more or less mostly dominated by something like a consensus, but with some exceptions and also extreme things. Especially we'll have something like these extreme opinions, which are a bit more than the one step less extreme opinions. And so you see a small peak here at the 0, and we'll see that these peaks become more common when we'll look at other politicized topics. Let's look at the left-right self-placement in Serbia. There we see a similar thing. So most people say, okay, I'm basically neutral on the left-right, but some people go for extreme left or extreme right. So this is extreme right, this is extreme left. So we'll see that these bins are larger. And then we'll see distributions here. The job chances in Serbia are assessed quite differently, but also quite extreme. And we again have this neutral and this other extreme bin. So we'll see that there is some kind of non-trivial structure which really deviates from the normal distribution. And now we come to things like, okay, these things are already not unimodal. They are just essentially unimodal in the sense that, okay, we have one large bin, so to say. But here, when we are more specific, we could say we have 4 peaks here: 1, 2, 3, and also one here, but it's not very pronounced. But still, it's a kind of peak because there are more here than here and here. That's what I mean with the peaks. So, and then now these are the typical multimodal distributions. The most polarized we find is this one for European unification attitudes in Serbia. So they are really polarized. Many people say it should go should be much more, and many people say it's already gone way too far. And still we have neutral. So we have a large sample, I think over 4,000 attitude distributions over several years, several topics, several countries of Europe from the European Social Survey. And this is by far the most polarized attitude distribution you get. So there's no issue which is more polarized. So that's how far you get in polarization, and it's a very rare thing. Trust in police is trust in police is maybe an example where you see that there are also these kind of off-center peaks. So there's a peak around 3, and here is a peak at 8 or 7. So, and this is another interesting structure, which I think may call for some kind of explanation why these peaks exist. So here we have a clear what we call pentamodal structure, so 5-bin structure or 5-peak structure: 1, 2, 3, 4, 5. And similarly, in the left-right self-placement in Norway, so it's not only that Serbia has this fragmented or polarized distribution. Also in Norway, you see that the left-right self-placement has this clear moderate right and moderate left peak. Also some right extreme people, but for the left extremes, we don't see this kind of peak. But anyway, the extremes are not so large in Norway, but still you see that there are these in a sense fragmented structure, or at least three modal structure. So this is more or less the empirical glimpse on the empirical data, which the rest of the talk is a bit about. Okay, so how can we now measure one-dimensional polarization? So okay, yeah, it is a measure of the whole distribution. So on a bounded scale, there is an agreement what is the minimal and maximally polarized. So whoever you ask, usually this is not very controversial. So minimal polarization is when we have a consensus, but it doesn't matter where it is. It can be extreme left, extreme right, central. So that is zero polarization. Also, maximum polarization is typically quite clear. We have two groups equal sized, maximally different in ideological position. So this is the uncontroversial thing. But this is unfortunately not enough, because first we saw, okay, we rarely have this distribution. Actually, we never have it in that extremity. We always have something in between. So the question is, how do we measure polarization in between this and that? Okay, just to cite some other researchers on polarization. So here you have at least three notions why this is polarized. You can say this is polarized because the groups are have a size parity; they're of equal size and opposing. So that's one aspect. The other aspect is they have maximal distance. That is the important thing because it's why it's polarized. Or you can say these groups, they are different, but they also have a group consensus. So that means they are really focused. So in a sense, so we don't have anything in between here, and that's why it's polarized. So you see already there are three aspects. I will not be able to finally disentangle this perfectly in the following, but I just want to raise awareness on this, and I think it would be interesting to integrate measures and which may capture these things. Okay, the measure we were looking at, trying to speed up a bit, is what we call average pair discrepancy or average pair antagonism, also relating to some other concepts. And the idea is you have the opinions I and J. So this can be 0 to 10 in our empirical data. So this is the antagonism, the difference between the opinions I and J. Here we have the fractions of the groups having opinion I or opinion J. So, and basically, as we have two terms here, we'll assume that we have kind of, we can think of, we pick a random pair, and then we'll measure the difference. So that's why it's the average pair discrepancy. We pick a random pair, and then this is the expected value in a sense of the antagonism. And this is just normalization factor, which brings this measure to a number between 0 and 1. So typically 0, no polarization, the consensus. Polarization being 1 is the 50-50 maximal extreme situation. So that's the measure we are using. Okay, that's what I just explained. We have the pair, we have the discrepancy, and then we have some normalization. It's also a notion in statistics called mean absolute difference without the normalization. Okay. So the conceptual measurement problem is now, okay, that we'll have the minimum and the maximum. So this is 0, this is 1. So, but what is in between? So we could say this is maximal diversity. This is polarized, but some people may say this is not at all polarized because we don't see any peaks. We don't see any group consensus. We don't see any gap, so to say. Here we see a clear gap, but it's not so extreme. Here we see an extreme gap, but it's quite unequal. So it's not a size parity. So we have a large majority on this extreme and a tiny majority on the other extreme. So in a sense, it's more polarized than this because the distance is larger, but in a sense, it's less polarized because it's not so balanced. So this is more or less the conceptual problem. One solution, which is not ultimately sufficient from an empirical perspective for attitudes, in my perspective, is this one, which comes from economics. Maybe it makes more sense there. I'm not so much into that discourse. It's from a paper from 1994, where I just present you one version. So the idea is you can have an exponent on one of these groups. Which is could then be called identification weighted polarization, because it means that you can think of, okay, when we'll have an exponent here, that means that this bin is weighted larger when it is larger. So in a sense, it means polarization is more when there are bins which are larger in a sense, because this would be still larger after the application of the exponent. So, for example, what we can do here is so this is what we call pole 1, because when we have pole 0, then we'll set one exponent, which is called alpha. I don't go to details here, but if you want to go to this literature, you will find that this makes sense. So pole 1 is this equation, and pole 0 would be the old equation just without this exponent here and with a different normalization. So, but both of these measures, pole 1, pole 0, they fulfill this general idea. maximum or minimum are the same. But and you'll see that even for this distribution, both measures would be the same. Also for this distribution, both measures would be the same. But for this distribution, we see a large difference. So the pole 0, the original one, will be quite large. So actually, from this perspective, from the old measure, average pair discrepancy, this would be the maximal polarized distribution, and these not. But from the pole 1 perspective, so this is the least polarized distribution because it does not have any pronounced bins. So that's one way to capture a bit of pole 1. But I still think it's not the final good solution for measuring polarization in attitude distributions or aspects of polarization attitude distribution. But at least it's already some good conceptual step also for attitudes. Okay, yeah, we can differentiate between more peaked and more uniform distributions. Okay, maybe this is a note for some people who know the bounded confidence model, but I'll not go into that at the moment. Let's look at the empirical data of attitude distribution even more. So we already looked at it. I'll explain a lot of it. This is again the European Social Survey. So this is just the numbers we have. So we have quite a lot of numbers and also quite some time, 2002 to 2018. Meanwhile, we should also have 2020 and 2022, but it's not in our analysis at the moment. So these are the typical questions. So these are the most politicized topics we selected. So left, right, European integration, and then some question on immigrants. Do you think immigrants undermine or enrich your country's cultural life? So this is another typically politicized topic. So these are the 3 core topics, but there are more. So this is the list of all topics we have in the data set. And now we looked at some other measures of polarization. So some people say you should just go with standard deviation or mean absolute deviation, or there is something which is called the disagreement index, which is some other notion to measure something like this. And you find that empirically, looking over all the 4,000 attitude distributions, when we compute the polarization in these ways, the correlations between them is very high. So essentially, all these things measure almost the same thing empirically. Of course, maybe you can. I'm pretty sure you can find differences in the pole 0 and the standard deviation. For some distributions, they make a difference because it's not the same measure. But these are then empirically not relevant because they're just not happening. So that is the point of this correlation analysis. So, but what makes empirically a difference is, for example, if you compare pole 0 and pole 1. So there we have less correlation, and when we'll make the exponent larger, we'll even can go to negative correlation. So that's why we'll then chose to focus on pole 0 and pole 1 as some measuring at least 2 aspects of polarization in a sense. Okay, so here you can see that it still doesn't make, it makes a difference. So here, so these are again 6 distributions and their peaks, and we'll see how the whole cloud of distributions looks in pole 1 and pole 0, and we'll see that there is at least some difference. If I should speed up a bit, I think I'll just go to the next without going too much into detail here, because what I want to do now is to say, okay, we'll solve these empirical regularities, like these pentamodal distributions, meaning we have 5 peaks, or at least a tendency to sometimes have 5 peaks. So maybe that is a way to model how attitude distributions look, because attitude distributions, they are for sure not well captured by a normal distribution or another simple unimodal distribution. They're also not simply bimodal, like whatever beta distribution with extreme peaks or something. So but there are more complex, having maybe these five peaks. So we'll try to make a very data-driven model of that, assuming we may have kind of latent 5 populations in the population. So we'll have an extreme left and extreme right population. This is motivated because we often have these kind of discontinuously looking peaks at the extremes. This is the left and the right. Then we'll have the central bin, which is also often very peaked out, and so not continuous with respect to the neighboring bins. And then we'll assume we have moderate left and moderate right, and these are normal distributions in a sense, but with their own mean, their own standard deviation, their own weight. So that's the idea, that we'll have, I think this is some French distribution. So we have a moderate left population, moderate right population. These are the bell shapes. So we add these up. So this would give us a central bin of this size, but then there is something like the excess of this, and this is another population. So these are the neutrals, which are neutrals not because there are moderate left, but from this a bit more to the right or the other way around. But these are the neutrals which are neutrals because of other reasons, because they are from a kind of neutral population. And the same with the excess of the moderate left and the moderate right. So this is our model now. We'll have several parameters, a bit too much from my perspective, but at least we have an idea that this may be a good fitting model to most distributions. And now we can fit the parameters, which means that we'll fit we'll fit 2 parameters for these 2 distributions, and then all the weight parameters for these 5 populations. That means 4 parameters for mean and standard deviation of the Gaussians, and 4 parameters for the weights for the 5 groups, because one weight is 1 minus the others. So we'll have 8 parameters for 11 bins. This is quite a lot, but still we cannot fit perfectly. And my guess is that you also cannot, although many people say with 3 parameters you can fit everything, but this is this typically people say which do not try it. But these are our goodness of fits. So we'll compare the goodness of fits in a sense like having a default model uniform distribution, and then compare how good is our model to the data, how much variance can we explain with this standard R-square measure, and we reach things usually above 0.95. So we'll explain most of the variance, but there are some exceptions where it doesn't work so well. Then we can go from there to kind of decompose the measure of polarization with respect to these estimated populations. So that is the approach we tried there. Ultimately, I say was a good step to do, but still, I think it's not the last say. I think, because it still doesn't explain these difference which I outlined in the beginning. These conceptual measurement problem. Okay. Okay, but this would be then the idea. So these are the populations, the extreme ones and the central ones, and then we'll have this purple thing which represents something like the polarization coming from the pole 1 thing and not the pole 0 thing. And the rest one is the cyan one is the is responsible for the polarization or the residual polarization, which is not explained by polarization of the extremist, polarization with respect to this group. And this purple aspect. So in that way we could decompose. So that would be a way to have the polarization measure pole 0 and decompose it into 4 aspects which sum up to the total polarization. That was our idea, and at least we found that these over the whole data set, we'll find that these 4 aspects, at least show some different aspects. Sometimes it's a bit extreme. So here we'll have negative correlation. So it's basically one explains the other in a negative way. But often we'll have these not so high correlations, or meaning we'll have at least a partly meaningful decomposition of polarization. That's still ongoing work. What can we do with it? We can say something like, let's look at European unification. Serbia is most polarized, then comes Austria. Then come others. Least polarized is Norway, and then we can decompose it and find that the Austrian polarization is more because of these aspects and not so much because of the extremists. So these are the things which we could analyze with this. Because of time, I don't go too much into details here. But another point is that we rarely find a super strong increase over time from 2002 to 2018. So there are just very, very few cases, and not the ones which you usually would think of, where you see an increase of polarization. For example, European unification opinions in the United Kingdom. This is the total polarization here, and you'll see it's not much changing. You may say, okay, there is some increase in the extremist polarization, some increase in the residual polarization, and here you see how the distributions evolve. So, and here, somewhere here happens the Brexit, but you don't see it coming not really you see it coming in this attitude distribution. Always there was a slight balance that it's a bit too much, but always most people say it's mostly fine, or they are neutral on that. That was the reality. So we don't see a real increase in polarization here in the general population, of course. Politics, media, party system, there may be differences, of course. Okay, so yeah, most polarized topics, we'll see that European unification is indeed one of the most polarized topics, going over all countries, all time step. Then also this immigration topic is fairly polarized, but the left-right scale is among the less polarized topics. Okay, don't go into details here. I already said a bit that this decomposition allows some structural exploration, but I think it should be further improved. I haven't pointed out it in detail, but yeah, believe me that there are no real consistent trends of increasing or decreasing polarization on any topic. So not in general, and also not on any topic over all countries. So we don't find that. You find some interesting stories. Sometimes they may also be related to what the media perception is, or the political or the elite perception of elite politics is, but it's not so clear. But yeah, what is more interesting from my more scientific perspective is that we'll have these non-trivial pentamodal shapes, and these are quite dominant, especially for the politicized topics. So for trust, happiness, which we just included because they're measured on the same scale, but it's not really political topic. But there we find much less of this pentamodal structure. It's more bell-shaped, less peak. But for the political topics, we often have this pentamodal shape where all the 5 modes are really pronounced. Okay, yeah. So what is the variation of attitude landscapes? So the variation for one topic country combination over time. So the time trend, this is, I think, the smallest. So there's very strong persistence. So also this non-trivial shape, these 5, that is quite consistent over time. So it's not like this really a measurement error thing that, okay, strange behavior of people. It's really every year again, every 2 years again, the distribution looks similarly with similar 5 peaks. So it's really a thing, not only measurement strangeness. So that variation is the smallest. There's more variation between countries for the same topic, but the largest variation is, of course, between topics. As I already said, these politicized topics have these pentamodal shapes, others don't have it. So there we have the largest variation, I think. Okay, so briefly in 5 minutes, something about an agent-based model, and then some comparison. So I think some people in the audience have some knowledge of this modeling. So probably it's quite brief for the people who have not looked much at have not dealt with agent-based models of opinion dynamics. But so maybe it's a bit fast. But yeah, that's just how it is. So what is the idea? So the idea is, okay, how do these non-trivial shapes like this or like this, how does it emerge? And maybe an opinion dynamics model can explain it with not much. So and the assumptions are quite strict or quite bold. So let's assume without opinion dynamics, this would be how attitudes look. Every attitude distribution would look like this, like a normal distribution. Standard assumption, we'll have an attitude is kind of it's a normal distribution. It's composed of several aspects added together additively, and then we'll have a normal distribution. for people who are not in social interaction. But now people interact with each other, and maybe they radicalize, maybe they assimilate or whatever, and maybe that forms these distributions. That's the idea now. So it's quite a different perspective. So the strategy is we'll start with theories of individual attitude change. So one person has an attitude, here's another attitude from someone else or some other information, and then this is the social interaction, and then it changes the attitude. That is the underlying assumption. And then we put this people which have some rules how they change their attitudes in social interaction in a society model where they repeatedly exchange attitudes. And then we'll study the attitude distribution which emerges as an emergent phenomena. And there is a field which is called opinion dynamics, which is doing this. Very theoretical, quite detached in the beginning, or often from the real world. Also for good reasons in some sense, because we often it's quite hard. We cannot really observe attitudes purely isolated out in the wild and their distribution and their evolution. So in a sense, it's every comparison with empirical data is already quite a challenge, also conceptually, I would say. Okay, but the underlying idea of explanation. So if we can explain the shape of an attitude distribution with such a model, what would it mean? It would mean we say attitudes without social interaction are normally distributed and always central. So there's nothing else. So it's really a strict assumption. We just say without anything, everything would be normal distribution centered at 5 on this 0 to 10 scale. And now individuals adjust their attitudes to repeated interaction, and that is all which we have. The question is, can this produce the fragmentation, a bias, a radicalization, a neutral consensus, or all these things? That would be the idea. So quite hard assumption, and let a lot of things emerge. And we'll see it's not fully successful, but at least somehow. And that's then also the open point. So just to make it a bit more visual, so we'll still assume that we'll have our people having attitudes, something like -3 to +3, or here it was 0 to 5, 0 to 10. But important is there is something like a neutral point, which is pretty clear, which is also the 5, and it has a special meaning. So when you are at the neutral point, you know you are neutral. So it is something, the central point of the scale. And this is now the attitude change function. I'll just stay with some kind of verbal explanation. Maybe I'll explain it. Explain it when I explain the parameters, because we don't have so much time. And this is a society model, but I'll just show you how the idea is. So we have these people, they have different attitudes represented by smileys. Here is how it would look as a distribution. So this is an attitude distribution ranging from negative to positive with some neutral in the middle. And the dynamics is the following. First, we'll pick one agent with an attitude. Then this agent looks as another agent. So this agent says something, and now this agent looks as this agent and somehow adjusts. Maybe it assimilates, maybe it picks it up as a signal, and then changes the attitude. That is the whole model, and that happens now repeatedly with always kind of random pairings. So another pair, so both are neutral, so both stay neutral. And then there's just one other process, which is similar to how we add noise terms in regression models. Now we add sometimes agents just idiosyncratically change their attitude to just another random number. So we initialize agents with random opinions, random attitudes from this normal distribution, and sometimes an agent does the same during the simulation. That is what is called idiosyncratic opinion formation. And the degree how often this happens, it's called the idiosyncrasy probability, and it's typically small in the following. So something like 1% or 5% of the times people make independent attitude formation. Usually they do these things like looking at others, getting influenced and adjusting. Okay, here this person by chance became more radical. And these are the parameters. I'll just explain to you here the main dynamics. So one thing, there's a strength parameter. We'll ignore that because it's just interrelated with others. We have a degree of assimilation. That is important because there are two different mechanisms. One is that agents just tend to reinforce themselves towards extremes. So when this degree of assimilation is 0, that means that whenever you get a positive message from the positive side, you'll get more positive, even if you are negative. Or even if you are already positive. So when you are quite positive, hear another positive message, you get more positive. That is kind of, you can say it's a bit of an emotional or a reinforcement thing. So when you get positive signals, you get positive, even if you are already positive. Same with negative. That is a degree of assimilation 0. And then we have degree of assimilation 1, where agents do not have this reinforcing thing, but they assimilate. When you are, that means you're slightly positive. You hear, or let's say you are extremely positive. You're someone who is moderately positive. So in this case of assimilation, you would not say, okay, I'll become more positive because I have a positive signal, but you would say, okay, maybe this other person is not so positive. I am super positive. Maybe I'll moderate a bit towards that. I assimilate to the opinion of the other. So that means always when you hear someone else's opinion, you have a tendency to go towards this opinion and not just take the signal as positive or negative. That is the difference of this parameter, and this is this is important. Idiosyncrasy probability I already explained. It's just the influx of the new independent opinions, which basically keeps the system not degenerating to some extreme attitude distribution. And then we'll have something which is called motivated cognition, which means I ignore attitudes when they are very far away. And there is a kind of factor of this. So the farther away another attitude is from mine, the less I take it into account. And there is some kind of latitude or bound of confidence. So this basically is the typical range until you take things seriously. And beyond that range, the effect of this attitude on you is 0 or at least small. And how much this is 0 or small is another parameter, which is called the acceptance sharpness. So when this K is super large, that means that this is a strict threshold. You accept everything which is in your latitude, you ignore everything which is outside. When the sharpness parameter is low, that means that there is a smooth transition. So just the further things go away, the less you take it to account, but it's never going to 0. And this is an important parameter, and this is something that this is important, is more or less an effect of studying this type of models that you see. Okay, that makes really a difference if this is sharp or not sharp. Okay, these are then the model outcomes. So these models, they often produce stochastically stable attitude distribution. And the interesting point is the stochastically stable. That means we'll have microscopic fluctuations. All the time, people change attitudes. So if you have an individual trajectory, it's never stable, so it's always changing. But at the same time, we have macroscopic stability. And this is also an issue which we indeed also find in survey data. So when you look at individuals, okay, some individuals are constant for all the time, but many individuals change their opinions and change their attitudes over the life course. But still, the stability of the macroscopic landscape is quite astonishing. So that it's really even within these small peaks and this pentamodal structure, if it is there, this persists, although there is fluctuation on the individual level. So and here you see that this model can produce different outcomes. Something like a neutral consensus, basically driven by assimilation, an extreme consensus. Here people start neutral, then they all go to the extreme. Or something like just persistent diversity, like originally, something like a small bias towards one side, but not extreme, something like this, and something like full bipolarization. And also sometimes we'll have situations where there's no stochastic stable attitude distribution, something like this. But we ignore this for now. Very interesting phenomena, but too much for today. Okay, here we'll have something like a phase diagram. We can say this is the extreme attitude. It happens for when the degree of assimilation is low, when people are reinforcing attitudes, then they will come extreme. When people oh, I think I made it wrong. Yeah, so I think these two should be exchanged. So when the degree of assimilation is high, we'll have central consensus, and when then the idiosyncrasy probability increases, here we'll have the kind of, we'll get back to diversity. So then people cannot radicalize anymore, even if they are reinforcing, then the randomness is too much. Okay, so we'll see that we'll have some kind of these parameters specify, okay, what the outcome is, but we have the option to have also, some intermediate things. This is without the motivated cognition, so a fairly simple model, has just these three outcomes, like, sustained diversity, moderate, neutral consensus, or extreme consensus. When we'll add, focus on this here, when we'll add motivated cognition, we'll have the phenomena of bipolarization, when we have people reinforcing themselves but ignoring after some distance other opinions. We can have the phenomena that two groups radicalize, one in this direction, one in the other direction. But we'll need this kind of motivated cognition that people ignore things which are too far away. When you are already fairly negative, you would ignore the positive messages. In that case, people can radicalize to this bipolarized distribution. But when we'll have this sharp motivated cognition, so really strict bounds, so that after some distance, the thing drops to zero, the influence, then we can have fragmented distributions, so even off-center peaks. But for this, we'll need this sharp transition. Okay, so these are the things, the qualitative replicative capacities of the model. It can show how radicalization comes, how neutral consensus comes, how polarization comes, and how fragmentation comes. But now, how close can we get to the empirical realities based on these very strict assumptions that there's just opinion dynamics and there's just a normal distribution without social influence? And the answer is very exploratory here only, but the answer is basically somehow. So let's look at these four distributions, which have some non-trivial structure. So this is one example. I choose one parameterization because of time. I don't go into the details, but so these are snapshots of the distribution. So you see, we'll have this three-modal shape like Norway left, right. But if you really compare it, we see, okay, this is what we get. What we can get, but this is how it looks. So these peaks, 4 and the 6 peaks, they are much larger, and this is not possible to produce with the model. So the question is, what else do we need, or does it make sense to continue the research in this direction? So we can simulate it in some sense, but not really to this extent. Another example. This is just other parameters. So we can also do something like, okay, strong central peak, some kind of off-central thing, and also these extremes somehow. So also not too bad, looks a bit like what, let's say, trust and police in Norway. But also if you go to the exact shape, so we don't get it. So these extreme bins, for example, they are not possible. When we want to have these extreme bins more extreme, then the thing breaks apart and these things vanish. So it doesn't work fully. So finally, another parameterization of other aspects. So we get this kind of distribution or this kind of distribution. So this was an attempt to produce the most polarized thing, which we have European unification in Serbia, large extremes and a large center. But we are either not able to produce the large center, or when we produce a large center, it's not so peaked. So it's really like we have a large center and we'll have these smoother shape, so it's also not the reality. That's basically it. So I'll have some talking points about polarization empirically, also, or some kind of this research program. What is the generative capacity of attitude dynamics models, and does it make sense to continue this research line? So hope I did not too long, still 10 minutes for questions. So thank you for your attention.